Hi everyone, welcome. So today we're going to talk about the iterative improvement from feedback for language models. So before we dive into the topic today, I'd like to introduce the Career Up for quickly for 3 minutes. So Career Up is a nonprofit organization. It's originally founded by Microsoft people, and now it has members across United States. For example, people from East Coast or Austin and the West Coast are all joining. And now we have more than 20 WeChat groups and more members also joining us. We're trying to expand the trust network of professionals and learn from each other and trying to inspire and get inspired in your life and your career. Hopefully we can get people and help them to get to the next level. In terms of core values, here are the core things that we always want to share, such as integrity, ownership, and growth mindset, volunteering for the community, diversity, and inclusion. So as a Asian community, sometimes there are many challenges or things that we are encountered in our career, such as like bamboo ceilings and also some other things, but we should change what we can. For example, we want to improve the soft skills, adapt to American culture, and serve your community. So Career Up, as a nonprofit community, we hold career-related events every Thursday from 7 to 9 p.m. PST. We also have a bi-weekly manager group, also the leadership fireside chat, and also we have mentoring program for part of the times annually. So if you want to join us, you can join us on WeChat group, Discord, or LinkedIn, or follow us on the YouTube. So today's events will be recorded and uploaded to the YouTube channel. Feel free to explore all the previous episodes. I'm sure you'll learn something helpful for you. So if you want to donate or contribute to the community, these are the links that can help us to get further. We'll share the link after this event. Also, this meeting will be recorded and it will be uploaded to the YouTube, but it's not representing for any of the club or company point of views. Okay, so let's get into something interesting. So this is the abstract for today's topic. We also shared in the WeChat post. Can take a look at here. And next, I'd like to introduce our guest speaker today. So Dr. Yuxi obtained his PhD in CS from the University of Alberta on reinforcement learning for real life. He is the lead co-chair for NeurIPS 2022 and ICML 2021-2019 workshops, and the lead guest editor twice for the Machine Learning Journal special issue. He authorized a 150-page deep RL overview with 1,300 plus citations. Opportunities and challenges, RL in practice, opportunities and challenges, and the iterative improvement from feedback for language models. He also reviews for AAI, ACM, CSUR, CACM, JAIR, JMLR, NeurIPS, TKDD, etc. Also a founder of RL for reallife.org. So I'll hand over to Dr. Yuxi, and let's get started.
Here you can see it, right?
Yes.
Okay, great. Yeah, thanks again, and it's great for me to share my understanding of iterative improvement from feedback for language models. Okay, let's see. Yeah, there are two big news for AI. One was AlphaGo, one was ChatGPT. So one question is, can we borrow ideas from AlphaGo to improve language models? For AlphaGo is absolutely superhuman. All the best players are beaten by AlphaGo. But for ChatGPT, there are still lots of issues. So for AlphaGo, the key techniques are deep learning, reinforcement learning, market research, and self-play. Yeah, let me introduce very briefly reinforcement learning. Here's the agent and interact with the environment, receive state, select action, receive reward, transition into a new state, and the objective is to maximize long-term reward. This is actually a very general model. It can model many things. Yeah, this is the detail of AlphaGo Zero, but I don't think I will introduce in detail here. But later, if you are interested, we can talk about this later. Yeah, actually, one thing is since we have audience from both East and West, and it's now a little bit late for East, so I welcome people to ask me questions, but I will, try to cover maybe try to cover in one hour, and then we if we have more questions, we can going on. Yeah, so for the license from AlphaGo series, especially considering for language models, here's a summary. For AlphaGo and many games AI, there is a perfect game rule. So we have perfect model, and then we have a perfect okay, something wrong with yeah, someone probably yeah, okay. Yeah, so perfect game rule, perfect model, infinite. So we can have infinite high quality or even perfect data. So with this, we can do trial and error, and we can follow some general policy iteration, self-play, and we can iteratively improve policy. And actually, from this, we have some very strong conclusion. Imitation learning is far from enough. If you see the figure on the right, those red ones, they are the programs before AlphaGo. So they build using some say heuristic, for example, heuristic search, or maybe using reinforcement learning or something. But all of them learn from expert plays. So they do imitation learning first, and then maybe they use machine learning or reinforcement learning to refine. Even for AlphaGo, it starts with the expert move, and then using reinforcement learning. So we can see that those right ones, the error rating is they are very much lower than those AlphaGo, especially AlphaGo Zero. AlphaGo Zero, it has it learned from scratch, no human play. So, but you can see the error score. Yeah, this is some measurement of the skill level. So the error rating for the AlphaGo Zero is the highest, and this has nothing nothing from human except the rule. So the conclusion is imitation learning is far from enough for AlphaGo and for chess and for many games AI. There are actually more examples to say that in machine learning is not enough. Language model. I think probably many of you, or maybe all of you, are familiar with this, but I just want to say, for the autoregressive language model, is the probability of next token given previous token. Actually, if you remember the reinforcement learning, or if you know a little bit, this is actually a policy. So the previous tokens are the state, and next token is the action. And the figure shows we have the language models are flourishing. There are many of them now, and especially the last half year, we count in days rather than in months. So every day we have some big news. So one key point I want to say is iterative improvement from feedback. This I basically treat it as a principle. Many, if not all, successful systems using this way. You can see at least some examples. They are actually very basic. For example, gradient descent in optimization, and in this figure, it follows this iterative improvement way. And there are many other things. Even the evolution of our humankind. So probably we need to follow this iterative improvement from feedback. Actually, ChatGPT, GPT-4, they follow this, but one issue I want to argue in this talk is they update not frequently, maybe every month or something like that. Yeah, here is basically the outline or the summary of what I want to talk. So basically, ground truth in the loop, and AI aims for optimality. AI adapt to human iterative improvement from feedback. General intelligence is approximation. And there's a study about language model, linguistic versus functional competence, grounding agency interaction, important for language models. And we want to bridge language model to real gap, and modularity and small models. Yeah, that's a way we probably want to go. Okay. And the conclusion is reinforcement learning is promising. Yes, since reinforcement learning is a natural way for iterative improvement from feedback. Actually, several of those ideas are provoking. So yeah, when we discuss them, if you have questions, we may talk. So here is a paper by some researchers from MIT. Basically, they are studying linguistic and functional competence of language models. Yeah, they study GPT-3, but I think basically it applies to GPT-4 and other language models. Yeah, basically, the conclusion is the language competence is pretty good, but the functional competence are not so good. Yeah, language, for example, the language rules, patterns, writing essay, those kind of tasks or skills. Functional, for example, like say factuality, or everybody knows hallucination, and maybe like reasoning, like mathematics. These are functional. Yeah, so language models, they have strong linguistic competence but weak functional competence. One question is, many people are pretty optimistic, and actually there are also something called foundational model, and people call it iPhone moment, or even OS of a new OS system. But when we're comparing with say the foundation, for example, highway or information highway, these are basically transparent. And if there are some errors, it's relatively easy to fix. But for language models, they are giant opaque black box. Not mention, some, for example, GPT-4 is proprietary, it's not open, so we don't know what's happening. So the question is, can we trust them as the foundation? This is a paper I think yesterday or maybe a couple of days ago, but on the Twitter, many people are talking about this, and it shows that the uh, with full test, the skill or the capacity or behavior of say GPT-4 and GPT 3.5 they change a lot. So we since they provide API and we need to rely on those API, but if the behavior of those API changes over time, then that's a big problem for uh for a system. For IT system, and we call API, those APIs are basically reliable. They won't change uh, over time. Basically they won't change, or they won't change too much, or they upgrade, but they are basically reliable. But if say language model like GPT-4, they change, for example, for this solving math problems from accuracy from 97 to 2%, that's a big problem. Even not like this much, if the performance or behavior change significantly, then when we build system, we need to be that's an issue. That's a big issue actually. And just recently, there is a paper talking about challenges. They discuss about design, behavior, and science. Actually, you can see. I think this paper is pretty good. I just browsed it briefly. But for example, in the middle, it says task not solvable by skill, not just by more parameters, more data, but we may need something. Yeah, maybe we need to go back to say symbolic way rather than just using neural networks. There are open problems for language model. Okay, so how to leverage language models? Yeah, they are good at language, so they are not good at function. So we leverage their competence as a language, but try to improve their functional competence. And we may improve language models by pre-training, by fine-tuning, by prompting. And there are some, so the say GPT-3, ChatGPT, they are pretty big, pretty giant models. So we may need parameter efficient approach. So we don't refine all the parameters. And we may augment language model with tools and APIs, so we can achieve various functionalities. Okay, so yeah, here is a summary. I think I like this, but yeah. So method to improve language models, pre-training, fine-tuning. Yeah, pre-training, brought T-file GPT-3, but there are some like Gato, ADA, Smart. They do planning in the pre-training stage. And fine-tuning, there are many of them actually. Besides supervised fine-tuning and RLHF, there are some new ways to do fine-tuning. And for prompting, we can do vanilla text, only text. We can do multimodality. We can augment with tools, and we can with some advanced techniques like search, learning, coding. For example, there is I think there's a popular paper like tree of shot. It use search. Yeah, actually, someone may want to ask me question about tree of shot. I have some critique for that. But yeah, let's go on. So one dimension is prompting. One dimension is feedback. There's for some approaches there is no feedback. For example, chain of thought, there is no feedback. But many approaches are developing method to benefit from feedback. For example, React, tree of thought, and many other approaches. They are trying to leverage those feedback to improve the performance. And another dimension is language model, whether we update uh uh input them or not when we after deployment. So for most method they are fixed. The language model are fixed. So for this talk, I want to argue that the model shouldn't be fixed. They should be input iterative from feedback. And there are only a few papers discussing about iterative improvement from feedback for the models. Okay, so just now we mentioned that there are, BERT T-file GP3, probably you already know them. But for those Gato smart ADA adaptive agents, they are trained for control. So they have planning or agency in the pre-training stage. Yeah, this is adaptive agent. Fine-tuning method, okay, super fine-tuning, and there are, for example, parameter efficient fine-tuning. Yeah, that's also super. And lemma, that's okay, there are RHF. This is reward modeling and reinforcement learning, and there are several ways, several method, new method to study this reinforcement learning, this learning from human feedback. Yeah, there are also some ways, directed policy optimization, try to not use reward modeling and reinforcement learning to do this learning from human feedback. But actually, I just want to say briefly, this DPO is specialized to certain model, but RHF, the idea is more general. Yeah, if I want to ask a question, we can discuss in more detail. Okay, so this is fine tuning. Yeah, this is ChatGPT. If you see the blog, then you know these 3 steps: super fine tuning, reward modeling, and reinforcement learning. This is prompt improvement. Chain of thought. That's a popular one. Yeah, there are several works. They try to improve prompt, for example, by learning, either super learning or reinforcement learning, or some techniques to improve prompt. Actually, prompt, that's a user interface for language model. So most method are about improving prompt. And here, basically, there's no training and no feedback during training. So I basically, yeah, I put them here. So no training and no feedback for those methods. But most methods are actually about improving prompt. Yeah, that's I think the main way for the current language models. Yeah, so here is one argument I want to say. Now many people are talking about, for example, prompt engineering. So there are lots of effort put into prompt to use language model. So that's something wrong. That's something wrong. So a mature AI system shouldn't ask human to do too much. But a mature AI system should try to adapt to human. So we still need to improve rather than ask human to develop complex prompt techniques. So the AI system itself should improve. So there are still lots of room. For example, that's also for the software system. We want to have better user interface, better user experience. So if we have to put too much effort into prompt engineering, then the UI, the UX are not good enough. So here is the closed loop feedback. So those methods they the feedback into account. But the problem here is I call them self-reference to fixed language models. So language models, they are not perfect, they are approximation. But if we do self-reference to fixed language models, then there will be something wrong. So all these methods, they don't update language model. They rely on a model, on a language model. So I think this is a core problem, a fundamental problem. But currently this is a mainstream. So actually this is, I think, arguable. It's kind of provoking. Some people may not agree with me, but that's my point. If you believe in iterative improvement from feedback, then we should improve the language model when we use them. So they shouldn't be fixed since they are not perfect yet. So actually there's a problem. Here I say self-reference, and probably now some people using language model to generate training data. For example, self-instruction. For example, the alpaca. Alpaca is using data generated from I think ChatGPT. So the problem is there's something called model collapse. When we sample data from a model, the model is not perfect, and when this iterate many times, there will be a model collapse problem. So we can see a example. On the bottom, it's initially we have a Gaussian mixed model, several Gaussian and they mixed together. We sample from those from this GMM, and then after sampling, we fit a model with those sample data, and then we sample from this fitted model, and then we do this many times. In this experiments, after 2,000 times, it collapsed into a couple points. So this is a problem. Many long tail data points are lost. So you may say that for example, self-instruct, they just do once, but the problem is on the internet there are more and more data generated from models, so we don't know how many iterations they have already experienced. So we don't know how many iterations these just like the example on the bottom, they may have already experienced many iterations, so the quality of the data may not be high enough. Okay, so ground truth in the loop, that's I think that's a principle. I'm pretty sure, but even for this ground truth, somebody even argue with me. I think that's not reasonable. So I think that's a scientific principle, ground truth in the loop. We should have it, otherwise there will be a problem. So that means we need to have trustworthy training data. If ever possible, we shouldn't generate training data from language model. If we do that way, the performance is upper bounded by that language model. We cannot improve over that. Yeah, if you are okay enough with that, then maybe okay. But for a better system, we shouldn't train a model with data generated from another imperfect model. And we need dependable evaluation feedback. So yeah, again, we shouldn't use a language model to evaluate. It's something like when we do a test, we shouldn't ask the student to self-grade by herself. Yeah, I think that's, if we do say this way, it's pretty intuitive. But nowadays you can see many people are generating data from using a language model, and many people are evaluating system using language model. There are something wrong fundamentally. Good news is there are something we can rely on. For example, game engine, since the game has perfect rule. And for code interpreter, code interpreter can tell you precisely whether the code is correct or wrong. And human feedback, yeah, human feedback actually is not perfect, but probably that's the best we can do. When humans are involved, we need to have some feedback. So maybe we have to find the best human rather than using, say, GPT-4 to do the evaluation. So when we do planning, we need reliable word model, and language models are not perfect word model. So when we do planning, there will be something wrong using fully rely on language model. Okay, so we need to have the environment in the loop. For example, for say robotics, those kind of applications, we need to have physical world in the loop. And if there are human users, we need to have human in the loop. So this is the ground truth in the loop. Okay. So AI aims for optimality. Okay, so the lots of language models, they are pre-trained using, for example, usually using self-super learning. So they don't optimize for downstream tasks. That's the pre-training step. So usually we shouldn't just use a pre-trained model. Probably should use a fine-tuning model if we trust the pre-training model have a good representation. And for the autoregressive language models, they don't have planning. On many works, they are trying to make it correct or feasible rather than optimal. So there are still lots of room for improvement. Okay, so here is a very strong argument, but this is basically based on two principles from optimization. One is multi-objective optimization usually will not optimize all objectives. Another is the more on the tighter constraints, the less chance to find a feasible solution. So when we talk about AGI, we are talking about handling many tasks. So we either want to optimize to have optimal performance for all those tasks, or we want to have good enough performance or some performance exceeding some threshold or some bar. So that's about constraint. So, these two basic principles in optimization basically means when we handling multiple tasks, we have to do approximation, or we have to do compromise. So something wrong with the goal of AGI. Okay. I don't know if people have questions, so maybe we yeah, if you have questions, please ask me. So language models are approximations. So there's a gap between language model and the reality. So similarly to community like reinforcement learning and robotics, we need to bridge the language to real gap. So for robotics, for autonomous vehicle, we cannot just train a model in simulation and then deploy them. For robotics, for autonomous driving cars. So why can't we train a model just from simulation and then deploy them for the language models or language problems? And in this case, a language model like GPT-4 is a simulation, is a approximation. So similarly to robotics and autonomous driving cars, if we are targeting for optimal performance, we shouldn't just use say language model like GPT-4 to train a model and then deploy it. Yeah, that's the point. We need to try to bridge this gap, the language model to real gap. Okay, yeah, this parrot. Probably you know there's an article, but I don't read here, the stochastic parrot. So grounding agency and interaction are indispensable for language models. So language model is about describe the physical world and facilitate these social interactions. And there are some actually this is based on a paper. It's actually not by me. We cannot learn a language from video or internet, from television, or by ourselves. For ChatGPT and GPT-4, basically it's still text only. It's from text. It doesn't have multimodality. It doesn't have social interaction with people. Yeah. So yeah, this is a figure I saw based on a paper. Experience ground language is EMLP 2020. Yeah, before ChatGPT, but I think basically I my understanding this paper, and so I spent some time to draw this figure. Basically, there are five word scopes. In the middle, it's label data, and second circle is internet text. That's basically GPT, ChatGPT, and GPT-4. And then next scope is multimodality, and then it's embodiment, and then social interaction. So for the grounding basically means we want to make the word meaningful and understandable and consistent with the word. For example, we say a color red. If we just describe in text, people probably cannot understand it fully. But if we show them a picture, we know it's much easier to understand this meaning of red. Or many things we need to ground them to the physical or social world. And for agency, that's about achieve some goal. It's about planning. And for agency, we need to have the interaction with the either physical world or human world. Yeah, so we need those five scopes for a language model to be sound and solid and closer to perfect. So the current language models, for example, GPT, is far away from that. What is here? Oh, here is about iterative improvement of language models. Here are these 6. There are not many. They improve the model while they are learning. So I think this is a right way to go. So for example, the first one is about some game diplomacy. They are based on some, like, I think it's GPT-J or GPT-2 something, and they train the model, and at the same time they also improve the language model and train another model for play, and also train the language model to understand the problem better, or give in the game they need to have some negotiation. So the game needs this language model to give advices about those negotiation. Not just advice, but how to negotiate. So they need to improve this language model to have a good performance. Yeah, there are those works. I think these are improving the model while learning. While learning, for example, those say planning, robotics, or game, or solve some prove some mathematical problems. But I think the key point is they improve these language models. Yeah, there are these examples. Let me skip them. Yeah, so when we want to iteratively improve language models, they shouldn't be too big. For example, like GPT-4, that's too big. To update is too costly. So we need to consider about modularity. And the left side actually is from that MIT paper discussing the language model and language and linguistic and functional competency. They give some kind of suggestion how to do the modularity. Actually, modularity is a long-term discussion or debate. For example, the right figure, they gave some kind of suggestion about what kinds of say how the brain may work and how the AI system should follow this kind of modularity. Yeah, so this is about modularity. And there are works about augmented language model with tools. So basically, this is related to modularity, since we yeah, when we augment language model with tools, basically we break the functions into modules, and those tools, they take some modules, and for tools maybe they don't learn or update, but the language models learn to improve those, learn to use those models. Learn to use those tools. Yeah, so like to former like Hawking GPT, yeah, there are some papers discussing how to augment language model with tools. Okay, now there are small models. Yeah, they are using all kinds of animals, and now there are more about like llama, like alpaca, koala, dolly. They are, yes, some kind of sheep, I think. Yeah. So the problem is if smaller, cheaper, yet similar performance, or even better, then why not use those smaller models? So maybe we should think about small and specialized language models. So yeah, here is a brief comparison. For example, GPT-3 is 150 billion, the parameter size. And there are some small ones like Gorilla is 7 billion. And this tiny story is only 10 million only, but actually it's pretty big. But you know, comparing with 175 B, that's pretty small. But the point is, say for Gorilla, they claim they only 7B, but they claim they surpasses GPT-4 with respect to API calls. On Tiny Story, that's only 10 million, but they can have fluent and consistent stories. On this 5.1, 1.3B, good coding performance. And actually, there's a new work. They use gzip and KNN. Actually, it's actually not even a small model. That's a tiny model. But they have good performance on text classification. And you know, Llama 2 is a news, and people already using 70 B Llama 2 on MacBook. But you know, these are changing. So the point I want to make here is small models, they can have pretty good performance. Then why not? Especially for small players, we don't have lots of resources. But here these examples give us some confidence, some encouragement to work on small models rather than just call API of those giant models. Okay, so here is my point. So we follow this modularity approach, and we have many modules, and they collaborate together. And the module 0 is a collaborator, coordinator. It coordinates many other modules. And yeah, the tools and APIs, they are also kinds of modules, but they don't learn, they are fixed. So for each module, including module 0 and module from 1 to n, each of them is an agent. In the reinforcement learning parlance, it's an agent, and the rest of it is the environment, and the agent learn from the environment. So here we can see there are n plus 1 agents. Each module is an agent, so they can learn gradually, iteratively, and improve themselves. Here, to make simple, those agents, those models, they learn by themselves. To make it more, maybe we should model it as multi-agent, but that's more complex. So we can just think of them as n plus 1 agents, and they learn by themselves. And we can put the large language models somewhere, for example, as user interface. They are good at language, and maybe smaller models are not good enough for language, so we can use say GPT-4 as one module to be a user interface. But if we can have a small model, for example 1B, to have similar comparable performance as GPT for say user interface, then we can use that small model. Yeah, so this depends, and this is a general architecture, so there are many possibilities here. And these models, they may be fine-tuned from large model, and they may learn from scratch. So it depends on which method has a better performance or good enough performance. Yeah, so it's a general approach. Okay, so yeah, this is from actually Sergey Levin's talk. Basically, he studied the beta lesson from Rishaten. Basically, learning and search are they can scale actually, and they are the basic method for AI. And Sergey Levin talked about data and optimization, both are important. Yeah, 2 months ago, I watched this movie again, and then I have some reflection. For Alan Turing, he decoded Enigma using search, and Deep Blue defeated Garry Kasparov using search, and AlphaGo defeated Listo using search and learning. ChatGPT basically using learning. And Rishaten summarized that learning and search are the general AI method. So probably for the next generation language models, we require both learning and search, not only learning. So far, not much search yet. So probably we need to think about search, how to do search in learning. So TOT is one approach, but probably that's not quite enough. Yeah, that just like I said, TOT or many of those methods, they don't update the language model. So we may do something to update the model and using both learning and search. So reinforcement learning, it integrates learning and search. Actually, this is from reinforcement learning textbook. Is reinforcement learning basically cover all those techniques and say, from dynamic farming to executive search to Mercado to TD learning. Yeah, it cover the spectrum of the whole spectrum of learning and search. Yeah, so there are more and more important role of experience in the AI, from agenthood to reward to experiential state to predictive knowledge. Actually, experience. GPT people may be very happy since when we talk about experience, that's basically about data. So GPT is basically training from data. So that's about basically a broad force of training with huge amount of data. But the problem is experience and the model, or if we're talking about philosophy, it's about empiricism and rationalism. And for AI, there are lots of debates about connectionism and symbolism. So we need both experience and model to make things say faster and explainable and transparent. So we need both data and model. And yeah, from Sage Sutton, he proposed some common model. It has both experience and model in this common model. Okay, so here I think everybody can understand or familiar. ENIAC in 1945, that's huge. But performance is just so-so. But it's breakthrough. But iPhone 2007, that's very small, but the capacity is very good. That's how many years? It's about 72, 62. Okay. So now 2020, the ChatGPT got taken us by storm, and currently there are still issues. The last half year there are many things happening. So what may happen, in the, for example, 2 years, 3 years, 5 years, we don't know. Maybe we have a much smaller model, but much more stronger performance. That's not impossible. So here is basically a summary of what I discussed. That's not the last slide. So this is basically last. But here I want to have a very strong argument. Autonomous agent is a big bubble. Why? So autonomous agent is still an open problem in AI. And agency is the prerequisite for autonomous agent. And currently the strongest language model, like GPT-4, they are learning with next token prediction, and it's not for agency and planning. So if a language model based on this kind of next token prediction, it shouldn't be the main player for agency. But the other models now, they are not good at say GPT-4, but GPT-4 they are not for agency or planning. So that's problem. Say people are talking about, say, Auto GPT, they are talking about, say, Baby AGI, those kinds of projects. Something wrong there. They cannot do autonomous agent. They will be hybrid. They need people to intervene. They need people to assist somewhere. So they are trying to be autonomous. So the way ahead is to build a model to handle tasks, tools, APIs, those planning stuff. So we probably should follow ideas like Gato, RT1, adaptive agent, or smart. They 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 are trying to build planning capacity when they are doing pre-training. Yeah, that's why I want to say autonomous agent is a big bubble. Yeah, be careful. It won't be as bad as autonomous driving. Uh, many tasks, language tasks, you don't just kill people, right? So not like autonomous driving, right? They are driving on the road, they will kill people if something wrong. But language models sometimes doesn't care even errors. So if that's the case, then okay. But if it's a high stake, for example, healthcare or robotics, then be very careful. Autonomous driving, although autonomous agent is not ready yet. And GPT-4 is not good enough for that. Okay, so shall we work together? Now we have this kind of modularity, we have small models. We may build many, maybe thousands of small models. Then we probably shouldn't just wait for those big players like say OpenAI, like Google, like say Microsoft, like say Anthropic, those big players. We probably should do something. We may, the open source community, decentralized way, and democratic AI, and we use the best of the wisdom of crowd. And maybe we do blockchain with tokens for the incentive. So that's how we want to do this, not just voluntarily, but we want to do it. For example, we can earn some token and we can work together and build strong models and let them collaborate, and we can have probably better system than any existing system. Okay, that's all. Welcome to connect with me and questions.
Thank you so much for your presentation. So next we are opening to Q&A. Does anyone want to ask questions? You can directly unmute yourself, or you can also type your question in the chat.
Oh, so are you happy with this? Do you agree with it or not? I think I think several points are pretty provoking. For example, this one. AGI is wrong. Is also, many people are talking about AGI, but I think that's wrong. And some people even argue with me about ground truth, the important or the necessary of ground truth. But yeah. So any questions? Yeah, I don't know.
Yeah, I do have questions. This is Justin Stein. I appreciate the talk. I'm trying to learn a lot, actually. I indeed learn a lot. And some questions just pop up from the practice. My question, what you mentioned is that for the smaller language model with modularity, right? And that's exactly what I really do agree on that. That's exactly what we are looking into for some enterprise domain, particularly for very customized task with basically a lot of private data and in a limited controlled enterprise setup. So what's your opinion about this area? How to break up or how to compress a very large language model existing there to make it feasible for enterprise domain of much focused task.
Oh yeah. What's your question? I mean that.
The question is simple. Let me make it simple. Okay, what are the common techniques to break up or to compress a large language model right now available for enterprise to make it to fit the LLM into their smaller or more focused task. You mentioned certainly pruning, right? All those things, right? That's a common practice. But what are the techniques, in your opinion, to basically compress the model or break it up into smaller modules?
Yeah, I think in my opinion, the key point is to make it iterative improvement from feedback. So how reliable feedback. The feedback may be from depends on your system. Maybe from customer, maybe from for example, if you are doing say recommendation or yeah, for example, like the say ads or something on the web page, maybe you're using say like click or how long you stay on the web page, those kind of information as a feedback. So my point is try to use those good feedback and try to not just keep the model fixed, but improve it as frequently as possible to and for too large models it's hard to improve. I think there are still argument whether we always need to have large models. I think it maybe depends on what kind of tasks you want to do. Yeah, so and also depends on how much resources you have. So, but it may be worth trying to build small models. But maybe you ask something about how to break up, how to divide. That's that part I think is probably depends on the task. And I think it's hard to give a very general suggestion about how to break up things. Yeah, I think it depends on your task. Yeah.
I definitely agree. It depends on the task or vertical domain where we are looking into, right? So this iteration, can it be really have relatively more automatic, or we have to rely on something like a penalty from the action we took from the previous decision, which can be costly. Or we can say allow some human intervention, right? Make it less automatic, but probably with domain experts inputs, things would be less costly. There are of course different ways or even hybrid of them, right? We are indeed looking into this, but in general we don't have a very good direction, and hopefully we can get some inputs from you. The iteration indeed is a it's not a common practice, but it has been existing there for so many years, right? And for the very controlled environment or very focused task, do we have something else? Not really for the intermodular interaction. Sometimes the modules are really, we don't need a multiple model or multiple modules. We just want to dedicate this module for that task and for this specific task. How do we, okay, the iteration certainly helps, but is there anything else? Oh.
Yeah, I think it still depends on the task. Whether we can automatically make the iteration or not. For example, say for gameplay, that's a good example. We can for gameplay we have perfect rule. Then, for example, chess, we have perfect rule, perfect score. So we can use those as feedback, the score as feedback to improve the system. But for some problem, for example, if there are say user in the loop, we need to have feedback from user. Then we may have to engage the user in the system and have the feedback, and then to improve the system. For example, like GPT, ChatGPT, I think that's their strong point, since they have customer, even GPT-3, that's already a popular tool for many people. So they collect lots of data, user data already. So yeah, generally it depends. If you have some good feedback, then you may have a automatic way. Otherwise, you may have to say rely on say user feedback or manually do something. Yeah, I think it depends on the system still. Yeah.
Okay.
Yeah.
I don't want to take too much time here, but another question is, it's how even for a specific task, depending on the task, can we make it less centralized? Say the LM, we can use some distributed nodes. Each one is of a very limited computing power, limited compared to clusters of GPUs for sure. And collectively, they can provide a generative decision. Like I don't know, like a federated learning stuff. Do you think LM and federated learning can be fused for that distributed environment?
Yeah, actually, I know a couple of papers. They are discussing how to do that. Yeah, just like you said, decentralized way. So, for example, I think it's some paper from Stanford. They have several sites, several points, and each of them take part of the work, and then they build a model together, but distributed or decentralized way. Yeah, so I think that's also maybe that's especially when those smaller model came out, I was thinking about that may be one feasible way. But when smaller model came out and with decent performance, then we may still do those way and take one advantage of like the crowdsourcing, right? The power of crowd.
Yeah.
So
Yeah,
that's I think possible. That's possible. Yeah.
Okay.
That's also
So,
that's why I put these slides. I think that's basically about what you are talking. Yeah.
oh yeah, absolutely. Yeah, because particularly Llama 2 released the new set, they are basically collaborating with Qualcomm to make it work on Qualcomm's chipset, right, for phones. That's very interesting. I want to see how far it can go. Thank you.
Yeah, that's possible. That's possible. Yeah.
Thank you.
Hey, Dr. Lee, I think it's a really great talk. Thank you so much.
Yeah, thank you.
Yeah, and initially you asked a question before Justin's talk, whether we agree with your opinion. I think the ground truth is fundamental. I totally agree with you.
Okay,
You can
generate
the model, generate something, there's a hallucination, there's a fiction, and it goes to use that as a data. It's already a lot of mess up around. So I totally agree on the ground truth and the approach of a human in the loop. So back a few years ago, 5-6 years ago, when I was leading Expedia AI Labs, what we built is chatbot for travel only, which we use entirely our travel data, which from the operation customer conversation. And when Transformer published We adapt the transformer algorithm mechanism and train with our data. So there's no hallucination, but the accuracy boosts very high. So it's in a way, it's our own large language model, but it's not huge. Yeah, similar way when we were doing, when I moved to lead AI for Change Healthcare, it's they process 1/3 of US claims, healthcare claims. So you need to understand all the ICD-10 forms and this and that. Use AI to evaluate whether the claim is correct or not and pass or not. Start from day one when we build that platform is a human in the loop. So there's a human coding expert. Their coding is medical coding, not really computer coding, right? A lot of work by the coding experts. In the past, only the human do that. So we use AI to do it. But when AI has no confidence on certain things, it pounded to the human pass. So it's a human in the loop. And once human give the answer, let's say assume it's correct, right? They're not always correct, but assume it's correct, AI also learn through that. So I think that those are fundamental points. If you start to losing the truth, you don't have anything, especially in healthcare, you cannot fiction anything. So it's very, very important. And the other question Justin was raising, to have a multiple models. The way when we were building travel or healthcare, what I envision is what we did actually. I don't see how you can have at the time, Lisa, we don't have that money and to have a one size fits all kind of model. You have different tasks. This one is chit chat. This one is about travel facing the hotel. This one is about certain other things. Those models has very specific tasks. They can finish that really well. And what I was introducing at the time is AI first, AI fabric. Basically allow the model result to be consumed by other model, allow them to talk, but not every topic needed by other model. So you pick your own. What's your interest? You know what I mean?
Thanks. Yeah, I echo your opinion, definitely. Yeah, I appreciate it. Thank you.
Yeah. So that way you only take what's needed. You don't need to have everything everywhere. And that has to be accurate. This verification accuracy is most important.
Right. But online, there's rumor, of course, saying ChatGPT-4 is literally a collective model of many submodels, each one for specific task, right?
Yeah,
and
16,
of course, they
16 or something.
16 or something. Yeah, I think more or less probably that's true. Yeah, I don't know. Yeah.
Depends on how well they implement. That's another question I want to ask Dr. Li. If you notice, Justin, if you notice, the last couple of days, there's several people published things saying Stanford researchers studied, tested the models. March GPT-4 is 98% correct. Probably certain things, math or something, prime number, so on. And now it's 2%. What happened?
This one.
Yeah, okay.
Yeah, to be honest. Yeah. I have not really recovered, but basically that's what you are talking about.
It's published today, yesterday, saying that it was a 98% correct. Now it's 2%.
那看准确率有点差。
你看呀，这个什么 accuracy，
3
月份的时候还挺高的，怎么到6月份突然降到这么低？
哎，怎么？Something wrong. Okay. Yeah, question.
黄色绿色是啥呀？它不是一个东西。
不同的时间嘛，就是同一个工具在不同的时间它的准确率。
So what happened with the performance drop?
it's a black box, so I don't know. Actually, I have not read the
Right.
cover yet, not yet. So I'm not quite sure. Yeah.
Okay.
But I want to just put it here to so that if it's an API, then it's not quite reliable. Basically, that says.
The lady just mentioned a very interesting observation, right? Actually, a natural question is, given a public black box LLM, and we all know ChatGPT can sometimes be misled by say, I gave it a question. It said I say, how much is 1 + 1, right? And this the answer is 2. I said no, I think it's a 3. Then ChatGPT may say, oh yeah, you're right, it's a 3. if a lot of malicious users providing this kind of inputs or interactions, so what will happen eventually, right? And how to handle this kind of a security problem is not just a hallucination by itself, but it can be misled by malicious attacks, right? And this I will say is probably a big issue we are facing. We don't want to have a AI misled by malicious folks who control the world and turn it into an evil place.
Yeah, that's true.
And they admit they have a hallucination and things. And one day I was searching, just not even GPT-4, just ChatGPT for some paper on certain topic, security or something topic. I asked for reference. It gave me 5 reference. I asked for link of each. Most don't exist. The link don't exist. So I think those issues are easier to solve. If you can't find you better find that link yourself before you share with the user, right? Anyway.
Yeah. Actually, a couple of days ago, I attended ACR 2023. That's the top conference in NLP. One thing I learned from that is I don't think the NLP community has a good method, good metrics or evaluation method for ground truth. That's a problem. But that's probably the current state of art. Ground truth is still a problem for NLP. People are still trying to work on that, and that's one problem, I think. So are you okay with my opinions or provoking points?
I appreciate it.
Yeah, definitely very enlightening. Thank you very much.
Okay. If you are reading, like Twitter or some blogs or something, my opinions, several of them are pretty different from the mainstream opinions, I think. So I need to argue with many people in with a group or Twitter. Yeah, I start to talk or argue with people on Twitter. I think that's a good place to learn. That's also iterative improvement from feedback. So I actively seek feedback from Twitter users to improve my understanding of NLP or large language model.
Yeah, when I see a lot of those happening, it's a hype, right? AI really, the ChatGPT done great job, no doubt. But I don't want people to hype too much. Oh, this is like a one size fits all to solve all the problems and things. Everybody taking it, especially when you talk about data being generated by the model, that's really dangerous. So my immediate reaction is I'm afraid get us into another winter. I was in AI the second wave long ago, and then you drop into the winter, right? Because people expect too high, expectation is too high. This time we have the big data, we have the compute power, but they still need to be realistic. Solving you're talking and Justin's talking, it's a particular domain problem. Get to learn that domain deeply. Then you can apply the right model, develop that model with all the feedback from, I usually building 2 feedback loop. One is a data to see how your data telling you you're doing. One is a user. You can work with the business unit, you can work with your customer, constantly checking whether you're grounded or not.
Yeah, I think just now I didn't mention this clearly or in detail. I think this is a nice summarization. Data without optimization doesn't allow us to solve nice problem in new ways. Optimization without data is hard to apply to the real world outside of simulator. So both data and optimization, or maybe both data and model are important. I think that's the point.
Yeah.
Yeah.
Certainly. Yeah, my starting point with the AI was when I was doing PhD is neural networks for optimization. So you covered all these words. And that time, the algorithm worked pretty well with the speech, with the, all sort of optimization thing with the image, certain function, but it won't scale because we didn't have big data, we didn't have compute. So now it's time, but we need to really make sure it served the purpose rather than, I'm a little worried that the fake data all over the place, right?
Yeah.
Actually, you're right, absolutely right. Actually, right now, a big area is to certainly to differentiate the generated data or news versus the real news, right? And also, some attorney we all read from news are already penalized by the judge because they cited some ChatGPT generated cases that do not exist.
You mean the lawyer, right? There was a lawyer.
Yeah. Some lawyers, multiple cases already. They were really drafting their legal documents using ChatGPT that really artificially generated some more wrong cases cited as a true.
Right? License no more lawyer.
Well, it will never happen. I think certainly a lawyer is definitely needed, just like a domain expert is definitely needed. Generative AI it can never ever be fully trusted, in my opinion. As regulation is kicking in, but certainly ethics is kicking in, but all those are definitely needed. We have a long way to go.
Yeah, another thing it's a side, mentioning is everybody should be careful because I think a lot of scammers are calling you, force you to speak certain things that I think they're recording your voice. Then can it generate send to your family, hey, I'm in trouble, you got to send me money. Just side talk.
Yeah, I'm happy you are basically on the same page on me, but I'm not so happy no one come to criticize me.
Oh, probably we are not as good expert in this domain as you are, right? I do have a question in general. It's how can make keep the privacy like there are cases when Samsung engineers early this year uploaded their test scripts for their commercial product, and the test ChatGPT really returned with some good script code, right, for their test cases, but that leaked the commercial secret to the public, and yet there's no way to reward it back to the.
Yeah, you don't ever do that. Basically,
I know. That's why I was asking a lot about.
The point maybe we want to ask Yuxi is where is the best starting point? When my usual thinking is taking the open source code and go build extend to your own, use your domain specific data to train. Therefore, your code is always with you. It's not going to be gone.
Yeah.
Absolutely.
That's also
I
what I'm thinking. Yeah.
Yeah,
something
which
by
I
yourself.
agree.
Yeah. Do
yeah,
something.
you reviewed so many different code, I mean, so many different models and so many different agents and so on. If you say I'm starting a new venture, it's in healthcare or something, what would be your thinking the best starting point? Certain models.
Yeah. You know, Llama 2 is out, so
Llama 2 is out. Yes, I see
Yeah.
a lot of talking on that.
like 7B, maybe I think even a professor can do something with 7B. So not mention a company, right? Even a small company can do 7B, do something. So especially if the privacy is an issue, you know, you probably just do something by yourself. I think, you know, there are some companies, they try to do, say, model as a service. Maybe you can trust them. Maybe I'm not quite sure. For example, you know, like cloud computing. So do you trust a cloud or you do your own cloud? I think that's a similar problem, right? If you don't trust a public cloud, then you build your own cloud.
That's
So
right.
yeah, that's similar problem, I think.
Yeah.
Yeah. So how do you like this? I think this is pretty provoking. You know, I know some people, they are pretty good, but they are trying to build autonomous agent.
It's just like, in my opinion, it's just like automatic annotation or labeling. You know, I think there's so it's a kind of dilemma, right? You basically trust machine to label something that is going to be consumed by itself. In that way, machine's hallucination, it will be consumed by itself as a truth, and then this thing will literally grow in a spiral way, into something uncontrollable eventually. Right? I think that's my opinion. I think probably, if I understand you correctly, probably that's similar. They are similar. Yeah.
Okay.
So yeah, if so, then I think this kind of automation, autonomous thing, which at least we should treat it very carefully. Yeah.
Yeah, I think usually before you can automate, you need to get understanding humanly. What is it? Usually I tell my team, before AI, there's HI, that's a human intelligence. You need to understand the problem deeply. Once you really done that job, you can automate many parts, but you have to consistently monitor it. So avoid the model drifting and all different problems happen, bias, all these needed. And if it's medical, healthcare, it need to be certified in some fashion. So yeah, I know when we were doing Expedia One, we were using the data, and literally initially they other people did for a couple of years, doesn't work because the data was labeled wrong by crowd labeling outside. So we took it over in AI labs, just basically labeled ourselves. But don't have to label everyone. You label certain amount, and then you have the machine, your development start labeled. You still have something wrong, then you check that through. And I know Uber, when I was talking with a Uber colleague at the conference, he said what they did is the labeling is a lot of trouble, right? So what they did is have the drivers or the operators, when they're working on certain things, maybe the operator answered the phone call. What is that? They mark it right there. So it's one of the column you need to mark down. What is the question coming in? How did you solve it? What is that? Is that, new passenger? Is that a car trouble? Is that whatever that is? For us, it's a travel booking change. refund, and so on. So those are the earlier time. Now you have a lot more tools, can do more, but still constantly monitoring, verifying, it's important.
Okay, yeah. Thank you.
May I have a question? Hello.
Yeah.
So
Yeah.
I'm a software engineer, so I'm not a machine learning scientist. But it sounds to me that at this point, autonomous agent is not the answer to a product, the mature product shape of a product. But how do you think of in terms of co-pilot? Is that the best way to, as you said, the ground truth in the loop? What do you think of this approach?
Yeah, so for Copilot, I think it's pretty good. On one hand, on the other hand, you need to spend quite some time to verify it's correct or not. So that's a problem. So it's not. It's far from autonomous. People or good programmers still need to get involved to verify the code. And actually, if you read paper about the code generation, and there's a metric called pass at one. That means when a language model generates a piece of code and it can pass, generate one piece and pass, just one try, that the performance is pretty low, like say 30% or something. So that's pretty low. And for coding, I think one good thing is there is an interpreter that can at least help check whether the code is executable or correct or not. And there are like a unit test. So these are good points for the programming language code generation. And programming language is a special language. It's different from a natural language. So since it's special, it's much more formal. So I think code generation is much easier than text generation. Yeah, but that's more objective, and so we know it's correct or not. So that's good. That's a good point. Yeah.
Yeah, I think like maybe for example, like Microsoft is releasing M365 and the Windows Copilot. I think many of the target users are, for example, these advertisement people or marketing people. So it definitely can save a lot of we can think of these creators' work. Sometimes they are still quite laborious, and doesn't really the stakes are not that high. So I think in that sense, this some with little bit of a human monitoring, human source on top of the like tedious work, in my opinion, like it is very actually it can help both the user and I mean, like the interaction process itself probably can improve the prompting if they have this feedback back into their prompt process. So yeah, that's just my 2 cents.
Yeah. So one thing I'm not quite sure. One thing is I'm not quite sure if there are. I think we need some study about, we need some measurement of those. For example, say code generation, for example, for non-professional programmers. Maybe one thing is if those code generation, they cannot generate code with very good say accuracy, then non-professionals, it's very hard for them to verify. And one study I'm aware of is Microsoft, they study Copilot, and they found that about 40% time people need to spend on say 35% spending on verify the code is correct or not, and I think 50% spending on how to deal with the system, something like that. So it's about half time they need to spend on the system rather than so the point is whether it's more efficient or not. Still, I think still needs more study to show that. Yeah, that's my understanding now. Yeah.
Yeah, makes sense. Yeah, maybe it's evolve in a way like when we're talking about the talents, we there is saying that we should grow like a T-shaped talent where we have a very broad knowledge of everything while we are expert on one or two verticals. I don't know, maybe in the future every company could have a collection of models where these models, they are like experts because they receive so many feedback. They're regularly tuned so that they are expert on some specific domains, while they also embody the broad knowledge of many aspects, because this is also helpful because as human beings, our scope of understanding is quite limited. So these are the low-hanging fruits for fields that we're not experts in.
Yeah, so I think that's one my point is if I think this is a if. So if this is if small models can like say 1B or even 10B, small players can handle, if those small models can have decent performance, good enough or even better, if better than for sure, right? We why not use it? If comparable performance, then small models are much easier to refine. So takes much less money and time. So one of my proposal is to have many of those small models and let them collaborate and coordinate them to finish some task or many tasks, rather than several single big models. And previous I talked about, if a single model trying to optimize many things, then there may be something wrong. That's about approximation or compromise. So my proposal is to have many small models and maybe one or two models to coordinate those models. Yeah.
But the challenge come to the coordination.
But so you can see this is an example. You can see there's Gorilla 7B and surpass GPT-4 with respect to API calls. API calls or like coordinating those models are basically similar. So we just train such a model to be the coordinator.
I see.
Yeah, but if this study is correct, then it says that this kind of coordinator, we can train a small model for that. And actually, 7B is not small; it's pretty big actually. But small players can handle that. And open source community can collaborate. Someone train this kind of model, this coordinator, and somebody train something for like math, English, some vertical or some function. Then people can collaborate.
Yeah, just out of curiosity, how much do you think this like a trend of evolution imitate of the human brain? Because it seemed to me that we have consciousness and unconsciousness, and there are different parts of the brain. Seemingly, each part is responsible for one functionality. However, they are so deeply and convoluted with each other, and it's not just like a linear mix of different models. So, any thoughts on that?
Can you briefly
So,
repeat your question?
for example, I heard there was a saying that there was a patient, half of his or her brain is removed. However, the person is still able to function well. And so it seems that it's not like the specific portion of the brain is purely solely responsible for, say, my leg movement or my arm movement, but instead, there probably are some backup mechanism in the brain. And also, so the functionality of my leg is not only determined by this part of the brain, but also like some psychological mental issues as well. So it looks like these different, the way the brain works is quite complex. So, but the way you are projecting this is like on top of this modular models, we have another layer of this orchestration model. It's going more like this evolution.
Okay, so probably you know more about brain than me. So, but I put this slide here. Sutton, yesterday he tweet. He said something like the next big thing is for people to understand people, maybe including brain. So, people don't, human don't know much about human yet, including the brain. So, but probably you know more about brain than I know. Yeah.
Never mind. It's just some random thought. Yeah. Thank you.
Yeah. Thank you. Yeah.
I think Jeff Hinton talked in his interview saying the initial intent start of this AI was he's a psychology, right? He wants to understand how human brain work. It got into out. Yeah. So we still don't fully understand. And there's somebody, I forgot which university, some professors also studying how to use a biology build. I don't know that they're progressing in a different direction to achieve AI.
Yeah, I think that's a problem. Maybe that's one of my critique about digital human. So I don't quite think that's ready yet for the digital human. The problem is we don't know human, we don't know ourselves good enough. So those language models, they are learning from, say, books or internet or those things about how we understand about human. And if you are building some digital human based on, say, language model knows, and language model basically learn from the human knowledge, and human don't know perfectly about human. So the model about human is not good enough. That's my so I don't think digital human, maybe they can do something, but there will be something wrong. It depends on say what kind of product, what kind of the users expectation of those digital human. Yeah, that's my I'm a big critic for many things.
I think to be truly like human, it would take quite some time, but in various domain function, whatever you call, it can pass human soon.
Yeah, that's possible. For example, AlphaGo, that's basically for sure. AlphaGo chess, those things. Yeah.
Another interesting direction is neuromorphic, neural network, right? That's some people call it spiking spike or spiking neural network. That thing is literally basically changing the very basic definition of neuron. Modeling after human brain, right? And certainly the current activation functions scales well. But the human's brain at neural level is not working probably that way. It may may not be the same whatever function we are using. How to combine that with the current deep learning models, architectures, or skills, I would say that can really bring something revolutionary in the future. Probably make the AI model much leaner in certain tasks like a human emotion or things like that, right? I don't know if it's a good thing or bad thing. It may make machine more like a human.
Yeah, we don't know. But AI will probably, there's a direction AI for science. So I think this will, AI will speed up many things. AI, science, engineering, arts, many things.
Yes, for sure.
And Justin, when you say not like a human, at the very low level, at least initial intent was like that, then you have neurons, and then between the neurons, there's a connection, it's synapses, right? And
right.
One can get excited, one neuron get excited, how does it pass through the message to another, and how they connect together. So that was the basic, but go deeper. Yeah, you're right. We don't know how exactly the whole works, right? You have a
but this is a big area actually. I was thinking that will be the future for the deep learning or neural network until all of a sudden ChatGPT exploded, right? Of course, maybe people forget about that, but sooner or later, that thing will become a focus again, I believe. Yeah.
That's part of it. And the other part is if you can develop something that surpass that, people may not bother to be exactly the same. Now,
oh yeah,
maybe you doesn't like that, but all things possible.
oh yeah, something like a quantum computing, right? That may really speed up everything at really multiple millions of magnitudes. Yeah, it's different.
And Dr. Li, in your last page, you also mentioned blockchain. So what do you want to use blockchain to pass the message?
Yeah, I think blockchain is, mainly it's for incentive. Open source is especially volunteer, but, and I think blockchain is, I think, copyright or ownership, those are issues. And, I think now it's not very fair, right? So say OpenAI, they got those data, they train it, and then they got model, they got rich. People generating those data, they don't share anything from that. So if we use blockchain, we can build this kind of system from the very start. If you contribute anything, you can get, some share of token.
So you want, for example, a celebrity's picture or somebody's novel, somebody's poem become fungible, right?
Yeah, similar.
Yeah.
But one thing is maybe if people interesting, we can even set up something like like coding, say coding generation, coding training. Then we can use one side we can use set up something, do coding, do training, and if people they can learn, they can teach, they can tutor, they can TA, those kind of things, marking, grading, and each of them, they may have some way to earn some token from the system. And during this process, we can collect lots of data, and these data, basically are pretty good. And on the other hand, we can train a model for the coding. So maybe that's a feasible way. But if we use blockchain, then naturally we have some kind of incentive system so people, token, okay, it's virtual, but we can just just like a startup, people will have a dream. We have some big picture, right? So token is something like that. But just in case in say 3 years, 5 years, this kind of system becomes successful, then people can benefit from this system. The token, just like say Ethereum or Bitcoin, it can worth lots of money. So so that's something I'm thinking, from the beginning we can consider ownership, say, and say copyright, those kind of things, and make, that's also, say decentralized, democratic, and it's also open source and wisdom of crowd. Yeah, that's something I'm thinking. Maybe possible. Yeah. Hello.
Yeah, I
Yes,
think you
hello.
can gather people who are, idea-wise, it's really cool. But for enterprise, if you're on the job for enterprise, you need to produce in 6 months, in 3 months, right? So it's a longer term project, but it's very good.
So maybe, maybe I can talk with Career Up to see if this is a potential project for them. But yeah, I don't know, but that's maybe possible. Yeah.
We definitely welcome such project ideas, but my limited understanding of Web3, I think the computation, like the layer one limits, is what is preventing from mass adoption. And it looks to me that this massive data training is beyond the capability of current Web3 infra. So we'll see.
Yeah, it's decentralized, so it depends on how many people interested in this kind of project. Yeah.
Yeah, but the thing is, when you like for example, Ethereum, the transaction per day, I think is like around 100 or so, something like that. So,
Okay.
so these kind of transactions are like both the training and the inference are usually expensive.
Yeah. I think there needs some initial investment for this. Yeah.
The crypto token and the token for the IAM. The terminology is really a little confusing, right? To me, I have to refresh my memory. I was thinking, I misunderstood you probably. I was thinking the token here you're referring is crypto token that can be somehow.
Actually, this is crypto. Actually, this token
Oh,
is
it is.
crypto.
Oh, okay.
Yeah.
Okay. Oh, so basically you try to use IAM for this crypto purposes, or what do you mean by incentive is like a digital currency, right? You are saying
Yeah.
I provide this incentive of what? I mean, I did not get it. For people to provide feedback.
Yeah. So basically, maybe we can build a blockchain, so people can earn tokens. That's like a
Right.
share of a company, right? That's like a share of stock, something like that, similar. So
Right now, what do you expect the people to do here?
yeah, people just like if we do say coding training or
Oh yeah. That's what I.
or
What I'm saying. Okay.
education.
Okay.
Yeah. So Yeah, probably you know what I want to say. Yeah.
Okay, I think so. I think so.
And also, it's possible for people to train some language model, and they can also earn the token if they do something. If they provide GPU or memory or hard disk or
I
something,
got it. I got it. I
earn
got it. Now
token.
I got it. Platform-wise, to enable LM basically, right? To make it stronger, make it more scalable.
That's
what it-
basically a
that's the-
decentralized way to
Yeah,
do education training, and maybe
right.
also training, also the language model. Yeah, decentralized
Okay.
way. Yeah.
Okay. Okay.
Okay, so we're at 9, we're almost at time. It's a really great discussion. And
Oh.
I really enjoy the conversation. But however, it's time, and so people should go to bed. So, but it's such a great discussion and great presentation. Thank you.
Yeah,
So,
thanks a lot.
yeah. Any other questions? Feel free to directly email or Twitter or follow LinkedIn on Dr. Yuxi. So we'll probably call it as a day. So thank you for joining.
Yeah, thanks for organizing and thanks for all the great questions. Thanks for attending. Yeah, thank you.
Thank you so much.
Yeah.
Thank you
Appreciate
for
it.
organizing. Thank you.
Thank you. Bye.
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 Thanks, everyone.